In this lesson, you will solve problems involving scale drawings and models. A scale drawing or a scale model is used to represent an object that is too large or too small to be drawn or built at actual size. The scale is the ratio of a length on a drawing or model to its actual length. So it's the model compared to the actual. I always say, when in doubt, if you don't know something, when it comes to scale models, ask Ma. It's always model over actual. This recipe right here is what you will use to solve problems involving scale models and drawings. You start out by writing a proportion with the scale as being 1/2 of the proportion, so the model over the actual, or whatever they say the scale is written here. And then that's going to equal the model measurement over the actual measurement. You will know 3 of the 4 pieces of the proportion, and you'll be able to solve for the one you don't know. For example, on a map, 1.5 centimeters equals 50 kilometers. If the two cities are 5 2/10 centimeters apart on the map, how many kilometers apart are they? Well, following the recipe, you write down the scale first, and it says the scale right here. 1.5 centimeters equals 50 kilometers. And then it says that the two cities are 5.2 centimeters apart on the map. Well, the map is going to be the model, and the model goes on the top. So that's going to be 5.2 centimeters. And you want to figure out how many kilometers apart they are in real life. Now let's go ahead and solve the proportion. 1.5x, or 1.5 times x, equals 50 times 5 2/10, which is 260. Now divide both sides by 1.5. And you get x equals 173.3 repeating, or 173 1/3 kilometers. In the next example, you are going to find what the scale is. One of the models of a dinosaur used in the filming of a movie was only 15 inches tall. In the movie, the dinosaur appeared to have an actual height of 20 feet. What was the scale of the model? Well, to figure out what the scale is, remember it's model over actual. So the model was 15 inches tall. And it appeared to have an actual height of 20 feet. So you could say 15 inches equals 20 feet for your scale, but oftentimes the scale's given in like something like 1 inch equals. So we're going to, for our second half, say 1 inch over x feet. We're going to figure out how much 1 inch is equal to on the real thing. So now if we solve this proportion, we have 15x equals 20. Divide both sides by 15. X equals 1 1/3, or 1.3 repeating. So the scale is 1 inch equals 1 1/3 foot, or 1 inch on the model equals 1 1/3 feet in real life. The model Mr. Vicario made of the building he designed is 25.6 centimeters tall. If the actual building is to be 64 meters tall, what is the scale of his model? Again, model over actual. So the model was 25.6 centimeters. and the actual building is supposed to be 64 meters tall. If we want to figure out what the scale is, let's figure out what 1 centimeter is going to be equal to. So 25.6x equals 64. Divide both sides by 25.6. And that works out to be 64 divided by 25.6. That's 2.5. So 1 centimeter equals 2.5 meters. Now the last thing we're going to do is we're going to find the scale factor. Scales and scale factors are similar, except that in a scale factor, you have to have the same units. A scale can have different units. So to find the scale factor, you want to first write down the scale and then change it to the same unit if it's needed, and then simplify if possible. For example, to find the scale factor of 1 inch equals 15 feet, you're going to want to first write it down. 1 inch over 15 feet. And now you're going to want to change it to the same unit. So we're going to change the 15 feet into inches. So there's 12 inches in a foot. 15 times 12 is 180. So 1 inch over 180 inches. Now that they're both in inches, we don't need to have that label anymore. And the scale factor is 1/180th. Basically, that means that the model is 1/180th the size of the actual thing. Now for the next one, 10 centimeters equals 2.5 meters. We're going to go ahead and write that one down. 10 centimeters over 2.5 meters. We're going to convert them to the same unit. So I'm going to convert to the smaller unit. There's 100 centimeters in a meter. So 2.5 meters is going to equal 250 centimeters. Now that they're both in the same unit, we don't need the unit in there anymore. Now we can simplify the 10 over 250 because they can both be divided by 10. 10 goes into 10 one time, and 10 goes into 250 25 times. So the scale factor is 1/25th. The model is 1/25th the size of the original, or the actual thing. Basically, 1 unit on the model is equal to 25 units on the real thing.